Okay guys, today we are going to leave off or kind of continue where we left off. So let's try this, okay? Let's start with having something that has an amplitude in it. Let's also put something with a period, and then we have our vertical shift. Okay, so just picking up from there, we have talked about, and there are some groups that got a little ahead of others, and that's fine. But let's pick up where we have an amplitude, we have something that helps us determine our period, and we have this vertical shift, okay? All right, so first, before we get started, let's just identify everything we have, because on the exam, it's really important that you can analyze the graph and pull all the information out and then do the graphing work, okay? So we know that we're supposed to look at our A for the amplitude. So I'm going to just take the absolute value of 1/2, which of course that's 1/2. So that means that my y-axis is going to have a maximum of 0.5 and a minimum of -1/2. Okay, so that's what my y-axis will maximize and minimize at. Okay, next part, let's look at B. Now there's a formula that helps us to determine the period, how our function will begin and how it ends. Okay, so here we have 2 pi over the absolute value of b. So I have 2 pi over 2, which the period is going to end at pi. That's straightforward. All right, the last thing, of course, is we have this -3, which is our d. Okay, so that means we have a vertical shift down 3. So let's write vertical shift down 3 units. All right, good deal. All right, so we know these 3 things. So now let's start graphing our function. Okay. All right, so I am going to make my y-axis, maximum is 1/2. The minimum is -1/2. Okay. I know that my period ends at pi. So the little trick that I was showing in class is, everything was about splitting the x-axis into fourths. So I'm just going to take pi, which is 180 degrees, divide that by 4, and that's why I have to do things in radians by 45-degree increments, okay? So when I put these little hash marks, good equal spacing, I'm saying that 45 degrees, we know that's pi over 4. We know if we add 45 to 45, we get 90, so this is pi over 2. And if I add to 90, 45, I would get 3 pi over 4, which that's 135 degrees, and then I have my 180. Okay, so these are all 45-degree increments apart. Okay, there's a little bit of an extra space there. All right, so I'm going to do this quickly the long way, just so you guys see where the numbers come from. Okay, and I like to do mine in pieces, and I recommend you do it. Now, I do have a lot of visual people, so if you feel like you can just sketch it and you see what it looks like, go for it. Okay, just make sure you give me my coordinates. Okay. So I'm going to ignore that I'm going down 3, and I'm just going to get ready to graph this piece right here. So here's my scratch work. 1/2 times the sine, 2. Now remember, x is in radians, so I'm going to take these different radians here, and I'm going to plug them in for x, and then I'm going to spit out a value. So when I plug in pi over 4, remember, all you're doing is basically 2 divided by 4, which is 1/2. So you have 1/2 times the sine of pi over 2, and that's that half, but there's a pi in the numerator. So what is the value of sine at 90 degrees? Well, your answer should be +1, okay, because that's a quadrantal angle, and the sine is 1 at 0, 1. So basically now I have 1 times a half, so bam, this is a half. All right, the next one, 1/2 times sine, 2 times pi over 2, and I leave that 1/2 times, so I'm just doing 2 divided by 2, so that becomes pi. Sine of pi equals, so now I know the sine of 180 degrees is 0, so that's why this value is going to be 0. 1/2 times sine, open parentheses, 2 times, 3 pi over 4, plugging in this one now, input-output function. So we're getting that sine. Remember, this is going to be 6 pi over 4, and that reduces to 3 pi over 2. So what happens when for a 270, when sine is 270, we should get out -1. So that's why this becomes -1/2. And the last one, 1/2 times sine, 2 times pi, so 1/2, and of course the sine of 2 pi is 0. So I'm going to say this is 0. So my final answer is going to be 0 for this one. Okay, so now I have these points, and I know my little 1s and 0s are probably in the way, so I'm just going to box what the final answers are. When we plug in those different radians, these are your y values, okay? All right, so now I'm just going to real quick sketch them on the side. So the coordinates are pi over 4 and 1/2, pi over 2, comma 0, 3 pi over 4, comma -1/2, and then the last one is pi, comma 0. Okay, so now we're ready to just plot our points. So we're going to get here 1/2. You know, this is at 0, 0. Sorry about that. This is at 0. This is at -1/2. This is at 0. All right, so when we sketch our points now, remember, no zigzag lines, make sure they curve. Boom. All right, so this right here is our y equals 1/2 sine 2x. But I have not shifted it again down 3. Okay, so I'm going to move to another paper because I do not want to run into all this math I did. Okay, all right, so real quick, what would this have? Okay, would this have a horizontal compression or a horizontal stretch? Remember, the function completed one full cycle in pi radians. So the answer you should have said is it has a horizontal compression. This thing got compressed inward, all right, because the parent function, remember, it tops out at 1, comes down through pi, and then it ends at 2 pi. So this had a horizontal compression. It got pressed inward. Hope we understand that. Okay, all right, so I'm going to switch pages real quick, and I'm going to re-sketch this. And now I'm going to do the last part, which is the shifting down 3. Okay, so remember, we got our 1/2, we got our -1/2, we have our pi over 4, pi over 2, our 3 pi over 4, and our pi. And our points went something like this. There we go. Sorry, I can't see my hand, of course. All right, here we go. All right, so now I'm going to take these points and I'm going to shift everything down 3. Now, if it helps you, because you just want to get this right, okay, write your coordinates. That helps a lot. Okay. And once you have that, I'm going to pick up another color now. I want to go down 3 units. Okay, so in my mind, what I'm thinking is my scale is at 1/2. Okay, we know 2 halves make a whole. So I'm just going to elongate because I'm going down here. And let's just do our scale. So if this is 1/2, this would be -1. This would be -1.5. Then I would be at -2. This would be -2.5. And let's go all the way down to 3. Again, good spacing and be neat. All right? All right. So this right here is 0, 0. And I want to go down 3. So of course it's going to go all the way down here. Seems like it's a long way. Okay, so this is now 0, -3. what was that? Pi over 4 and 1/2. Okay, so watch my pen. So this right here is a half. Another half jump makes a whole, so that's 1. And then there's 2, right? And then there's 3. But remember, I was at my 1/2, so watch it again. This one right here would be 1. This is 2. There's the 3, okay? Because I'm a half above my x-axis. So I'm going to put a dot right here, and I'm going to write my point, 1/4 negative 2.5. Okay, this one, again, pi over 2 was at 0. So I'm going to come all the way down here. And you're going to get to see the midline form right in front of you because d is negative 3. All right, now watch this one. I'm here at negative a half. So this is a half to me. This is a whole. This is another half. This is another whole, so I've made 2 now. Here's another half, right? But the problem is I need to go a little bit more half, so I'm going to go right here. I'm just going to kind of ballpark this one. Try to be really perfect about this, guys. All right, here we go. So just to show your scale, come across here. I'm calling this negative 3.5. All right, good deal. And then the last one, this one's straightforward. It's going to be at negative 3 because it was at pi, comma 0. So this one's going to be right here. And let's put our coordinate, pi, comma negative 3. This one is 3 pi over 4, comma negative 3.5. And you can put decimals if you want. And this one is pi over 2, comma negative 3. Okay, so now I'm going to use another color. I should have did blue dots, sorry. So here, okay, and here's that midline, and it should go through here. So please write down that d is equal to negative 3, okay, because we know where we got that from. That was from the back number, the negative 3, and that's our midline. I have a cold. All right, so negative 3. That's the midline. That's where we should end up. Okay, now I'm going to be just a little clever. I hope this won't distract people too much. But remember, the original equation we have is y is equal to 1/2 sine 2x minus 3. What I'm going to ask you guys to do is let's try to throw a reflection in here. And I'm going to use a red color to do this. So here's my midline. So I'm asking you to graph this one now on the same place. So let's use another color. So I'm going to do y is equal to negative 1/2 sine 2x minus 3. So that one's straightforward, right? We already know that this is what we have. And let me go back here and label this. Y equals 1/2 sine 2x minus 3. I'm just going to now just reflect. So this one's going to stay right where it is. It's like this is a mirror. Okay, this is our new x-axis, and we're going to go ahead and reflect across it. Okay, so I'm a half away here. So this would be half here. So I'm going to put a dot there. This one is going to stay because it's in between, right in the plane of the mirror. This one is half away here. So I'm going to come up here, trying to eyeball everything, and then here. So basically, now, if my teacher asked me to do a reflection, that's what it would look like. And I'm sorry I chopped off through the y. Okay, so again, this one right here is the red one, and this one right here is the blue one. Okay, I know that's a little messy. Okay, so you can do this in steps, and then maybe as you can see everything, you can just have your final sketch, which would be this. Make sure you give me what the function is for that particular graph, and then you'll get credit for it. All right, let's move on now. And again, I showed a reflection. We should understand amplitude. We should understand vertical shifting. So now let's do a phase shift real quick, and then we're going to go on to cosine.